Hello, everyone. My name is Roger Mazzella. I'm a senior product manager with the Cute Company. Been working with the Cute Company for 5 years and been in charge of the product in the medical device and medical industry. Today, I'm joined by Jim Tieman from Neocis. Jim, would you like to introduce yourself?
Hi, Roger. Yeah, thank you very much. It's great to be here. My name is Jim Tieman, as he said, and I am the Director of Software Engineering at Neocis.
Fantastic. So, Jim, can you just briefly describe what you're doing at Neocis and the type of projects you're involved with?
Sure. So Neocis builds a dental surgery robot, and the robot is primarily used for implant surgery. So implant surgery comes into play when someone has lost a tooth or multiple teeth entirely and is looking to get replacement teeth. And what usually happens without a robot is that the surgeon will, so the patient comes in to have surgery, and the surgeon will make an incision in the gum, pull the tissue away so that he can see the bone, the jaw, and they use a hand drill and drill holes into the jaw, and that gives them a place to put what's called an implant. And an implant basically is an expensive, sophisticated screw, and that just gives them a place to actually put a crown or a bridge into the patient's mouth. So we build a dental surgery robot, and what happens with a robot is instead the patient will come in for a preoperative CT scan. We do a 3D reconstruction of the patient's anatomy from the CT scan, and then the surgeon will plan the surgery virtually. So what that means is they'll put a virtual implant into that 3D reconstruction, or multiple implants, where they want the real implants to be during the surgery, where they want to place the real implants during the surgery. So it gives them the opportunity to be a lot more precise. You can look at the position of the implant that you've planned. You can measure distances between where the implant is and other anatomy that you might want to avoid, roots of other teeth, nerves, the sinus cavity. And then you can also look at the density of the bone. You can look at how it's positioned relative to where you want the crown. And you can precisely place that implant in the optimal location for a base to support the crown or the bridge that's going to be installed in the patient's mouth. So all this gives you the opportunity to have a much more sophisticated, much more accurate plan than is possible if you're just using a hand drill and doing the surgery kind of the traditional way. And then, of course, once the surgery actually happens, it's the robot's job to get the surgeon to those locations that have been planned. I should mention, probably at this point, this is a medical device. It's classified as a Class 2 medical device, which means it falls under the purview of control of the FDA. And we, of course, have to do what's called a 510K application to the FDA to actually get permission to market and sell the robot. And that's just part of the process that we go through. It requires a lot of documentation and testing and that sort of thing to prove that we've made sure that the device is safe and effective on patients.
You know, Jim, I love hearing how our customers and the products that our customers are developing, especially these kind of intricate and complex products that are out in the market today. It's also very interesting with regards to the surgical robot, that we're in surgical robots, but we have to remember that despite this being the dental industry, it is a medical device. So thanks for mentioning the class of device and the medium, kind of safety risk to the patient. So as a follow-up, you really described how the robot operates very well. Where does Qt fit into all of this? How are you using Qt and leveraging the power and the versatility of Qt to help deliver such an innovative technology to the industry?
Yeah, so the software that we develop for the robot really, it goes into two categories. First of all, there's the software that actually operates the robot, so moves the arms, senses the location of the patient during the surgery, those sorts of things. And it's also the user interface. So there is, a need to have somebody drive the robot, and there's a user interface for doing all of that. Besides that, there's the planning software, which I mentioned before. And you can, in fact, plan the surgery if you wish on the robot itself, but most people prefer to plan on their desktop. So we have a separate desktop app that is used for the planning that I discussed before.
So it seems like you're really leveraging a little bit of the cross-functional capabilities of Qt, having a few different platforms that kind of go into the ecosystem of driving this robot. And you mentioned, the UI on the robot and the planning software. A question I have is from a development perspective. How is Qt a little deeper of how Qt is being utilized, and how does that translate into benefits for you? We mentioned some of the cross-platform, and I think you alluded to some of the cross-platform development. But in using Qt, and you have a lot of options out there. What kind of value, what kind of a return on that investment of developing in Qt and using Qt are you recognizing?
Yeah, so I guess maybe the best way to answer that is to tell you a little bit of a story. When I started with Neocis, we were a Microsoft Foundations classes application. And for those of you who are old enough to remember MFC and perhaps not quite old enough to have forgotten it, it was the state of the art in how Windows applications and Windows GUI applications specifically were developed back in the 1990s. So we wanted to give our software a little bit more of a modern look and feel, and also just kind of give it a facelift. So Qt provided us a great platform for being able to do that. We incorporated Qt, took out MSC, incorporated Qt, gave it a whole new UI layer, and we were able to achieve all of the things that we were trying to do from a user interface point of view using Qt. So it was very effective in that way. The other thing which you alluded to, which is very important to us, obviously, is the planning software needs to run on the surgeon's desktop. They don't want to always walk up to a robot to do their planning, right? They want to be in the environment that they're most comfortable with. So the other big advantage to Qt, obviously, is the multi-platform support. So we wanted to, of course, run on a Windows environment, but also, some of our surgeons have a Mac or some other environment that they wanted to run on. So we wanted to be able to really provide that cross-platform support and be able to support our surgeons in the environment that they're most comfortable with. Qt allowed us to do that.
In my conversations with customers, I get pulled into a lot of customer discussions and especially obviously in this industry. And we talk about cross-platform, functionality and the value of that, but to hear about it and hear it in real life, how it's really being leveraged and used and the important ways that are being used is really phenomenal. Thanks for sharing that. And understanding that the medical device and dental industry is ever evolving. And, you mentioned something about modernization. I've had a few talks in the industry where, the medical industry, the dental industry is a little bit behind the modernization that we experience in let's say, the consumer industry. So understanding that, things are going to change and what's modern today is going to be outdated tomorrow. What does the future hold for Neocis? What kind of things on the horizon are you guys planning that you can share with us?
Yeah, thank you for asking. Well, it's an exciting time for us. We're doing our best to innovate, to create a disruptive technology in the dental space, and I think up until now we've done a really good job, and I hope we are able to continue to do that. For us, it's mostly a matter of making changes in two different areas. One, to add what's called new indications to the robot. That basically means new types of surgery. So I can give you an example of one of those that we're investigating. If a patient is coming in to get an entire jaw or a majority of an entire jaw replaced, that very often have a single piece denture installed after they get their implants. So a denture like that is flat across the bottom. However, the anatomy of the jaw very often doesn't support a nice flat surface. It will be whatever shape it decides to be. So what typically has to happen is they need to go in and flatten off that area to give a nice base on which they can install that denture. So this is a very difficult operation for surgeons to make sure you get with it, by hand, can get a nice flat surface. But this is something that for a robot is quite easy. So we're looking at things like that the robot can do that are actually very challenging for a surgeon. So that's one area. The other area that we are looking to increase the support for the process in general is having to do with the ways in which we support the whole patient experience. So patients don't usually come into the doctor's office looking for implants. They come in looking for teeth, right? And so we need to understand that this is a patient experience, that they want to understand as they walk in what the final outcome is going to be, what they're going to look like, what their smile is going to look like. And they also need, teeth put back in to their mouth. So those teeth have to be fabricated. So the other thing we're looking at is, how can we support more areas of this entire process, the entire patient experience?
Jim, thank you for mentioning the patient experience. As technologists and me being a background in electrical and biomedical engineering and the work that you're doing, sometimes we get so bogged down in the technology and the features and functionality, and we lose sight or can lose sight on the patient experience. And especially with the dentist, right? People are afraid to go to the dentist. They don't like it's not a very pleasant experience. So that patient experience, I'm so glad you mentioned that, because I think that patient experience and keeping an eye on the prize on what the end result is and the end goal is so very important, especially in our industry. So thank you for that. So I think we're about out of time. Jim, I want to thank you so much for this enlightening 15-minute fireside chat. I appreciate you sharing with us, not just how you're using Qt, but how it paints into the bigger picture for you and your company and the goals you have in the future. I'll leave it to you. Any last comments or messages you'd like to give to our audience?
Well, thank you, Roger. Thank you for having me. I really appreciate being able to talk about what I do and the excitement that we have around the innovation that's going on in dental robotics. I'm really excited, not just for what we're doing, but also for what Qt is doing. It's been a great platform for us, and excited to see what emerges next, because we certainly can use some new technology as we figure out how to move our product forward as well. So thank you, and I'm excited for the future here too.
Well, thanks, Jim. And as a product guy in the medical industry, I'm looking forward to continuing to work with you going forward to make sure that everything you guys are trying to do, that we can support you the best we can. So thanks again for the time, and we'll be talking again soon.
Thank you, Roger.